Hi students, today I am going to explain what is heat content H. It is also called enthalpy, heat capacity C or entropy. So heat capacity C and entropy S. So these three concepts we'll see now. What is enthalpy or heat content? Let's see. So the total heat content of a system at constant pressure is equal to the sum of internal energy and P into V. So P is the pressure and V is the volume. So when we take the one system, so the total heat of that system when the pressure is not there. So when the pressure is constant, we are not changing its pressure, then it is equal to the sum of the internal energy, the energy which is present inside it, internal energy, plus P into pressure into volume, whatever is the pressure present in that and volume. So volume it occupied. So H is equal to E plus PV. So the heat contents depends on what? Three factors here. E, nothing but internal energy, P, pressure, and V, volume. And it is a state function. What do you mean by state function? State function means it depends only on the initial state and the final state. It will not depend on the path, how it is changing, how the states are changing from solid to liquid, liquid to gas or whatever it is. When the change in state occurs, what is the path? That it will not depend. It only depends on the initial state and the final state. So it is a state function. So enthalpy is a state function and it is a total heat present in a system when the pressure is constant. So H is equal to internal energy. So E plus pressure into volume. So when we see the enthalpy of a system, we cannot measure this directly. So we have to take change in enthalpy. So we can measure change in the enthalpy. So delta H is equal to, delta H is nothing but change in the enthalpy, is equal to H2 minus H1. So this is the initial state, H2 is the final state. So H1, so total heat in the first, total heat of the system in the initial state, it is equal to E1, how much internal energy is there in the first, plus PV1, and H2 is equal to E2 plus PV2. So delta H is equal to, we just substitute there. So H2 E2 plus PV2 minus E1 plus PV1. Here we can see we take same variables, same side. So E2 minus E1 plus PV2 common. So PV2 minus V1. So we'll get delta H is equal to, again E2 minus E1 is change in the internal energy. So delta E plus P change in volume, V2 minus V1. So P delta V. So delta H is equal to delta E plus P delta V, because pressure is constant here. So that's why there is no change in the pressure. Change in pressure is not there. Only change in the internal energy, change in the volume. So we can differentiate it like this. Psi H is equal to psi E plus P psi V plus V psi P. That is equal to, this 2 is nothing but a change in heat. So that is why delta Q plus V psi P. So that is the final equation. But if we remember this one, that is enough. Delta H is equal to delta E plus P delta V. Then next is heat capacity. So that is represented by C. Heat capacity of a system is defined as the amount of heat required to raise the temperature of the system by 1 degree. If we take one system, so whatever is the amount of heat we are giving to raise its temperature by 1 degree. So for different substances, this heat capacity is different. For example, when a sun is falling near a beach, so the water is also getting heat and the sand is also getting heat. So the heat is given to that both systems, if we think water and the land as two systems, which will get more heat faster, obviously sand than water. So the heat capacity of these both are different. So different substances will be heated at different temperatures. So at different, so more amount of heat is required to raise its temperature for some substances. For less amount of heat only, the temperature will be raised for some more substance. So it is different for different substances, and we can give its formula, right? C is equal to dq, means amount of heat given by to raise its temperature, dt. So C is equal to amount of heat given to raise its temperature, dt. So dq is equal to, we know that dq is equal to dE plus P dV. Yes, no? Then C is equal to, in the place of heat dq, we write dE plus P dV and by dt. So like this we can write differentiator. Then heat capacity, when we take at constant volume, so volume is same, what is the heat capacity? Then CV is equal to dE by dt when the volume is same. So dE is nothing but change in internal energy plus dt is change in temperature, right? So when the volume is same, here volume is same, dV is same, so dE by dt. So change is constant volume is dE by dt, so V. So when volume is constant, change in temperature makes change in internal energy. So when the volume is constant, if temperature changes, internal energy also changes. So what happens when we keep pressure as constant? Then Cp is equal to dE by dTp plus Pdv, right? E plus Pdv. We differentiated it. dE by dt, pressure is constant, P plus P dV by dt, pressure is constant. So H is equal to E plus PV. So dH by, on differentiating it, dH by dt, pressure is constant P, that is equal to dE by dt, pressure is constant, plus P dV by dt, pressure is constant. So Cp is equal to dH by dt whole to the power of P. So at constant pressure, what happens? Change in temperature will change in enthalpy. So what is enthalpy? Enthalpy of the system. What is enthalpy? We already read what is enthalpy in the first only, that is heat content. So whenever temperature is changed at constant pressure, then what happens? The total heat will be changed. So that is nothing but at constant pressure, change in temperature will change the total heat of that system. Then what is the relation between constant pressure and constant volume? So Cp minus Cv is equal to, Cp is nothing but, we already calculated, Cp is equal to dH by dt whole to the power of P, or we write this two, dE dTp plus P dV dTp minus V is nothing but dE by dt whole V. So this we substituted. So dE by dt P, this one is equal to, we differentiated this. So psi E by psi T V dt. So by differentiating, that psi E by psi T V plus psi E psi V T plus psi V psi T P plus P psi V psi T P minus. So on differentiating all, so by differentiating we will get Cp minus Cv value as R. So last, Cp minus Cv is equal to R. We know that Pv is equal to RT, ideal gas equation. So P into psi V by psi T into pressure is constant is equal to R we got. So Cp minus Cv is nothing but R. So that is the final equation. So the relation between Cp and Cv is nothing but gas constant R. So next, what is entropy? So entropy, we know that it is a quantity which tells whether a chemical reaction or a physical change occurs spontaneously in an isolated system or not. So whether a chemical reaction or physical change, it will occur spontaneously or not, it will tell. So ds, change in entropy, is equal to amount of heat absorbed reversibly by temperature. So when we give heat to a working substance, it will use some of its energy, that is called available energy, and remaining it will not be used for working. So it is called unavailable energy. So this entropy is a measure of this unavailable energy. So unavailable energy is equal to S into T, entropy into temperature. So when there is an increase in the entropy, so what happens when we give some heat? So the particles will get kinetic energy and it will start moving. So when it start moving away from each other, what happens? Then they will change to a very disordered state. So that is what the entropy increase will cause. So increase in the entropy means change in ordered state to less ordered state. So when we give some energy, the kinetic energy maybe, so the particles start to move, changing from an ordered state to less ordered state. So this entropy is a measure of this disorderness of the system. So change in entropy is equal to delta S is equal to S2 minus S1. So it is also a state function because it does not depend on the path. It depends only on the states in the initial and the final state, whether it is changing from solid to liquid or liquid to gas. So these are the three concepts, very important concepts of thermodynamics. Thank you.